So Sebastian, we may start now.
Okay, perfect.
Now we have 18 number of participants. So
18, okay, yeah.
So welcome all of you in the webinar of Nepal Hydropower Association. So this is the fourth episode under the Energy Forum of Nepal Hydropower Association. So we are having different topics under the theme of hydropower. Today we have topics in innovative ultrasound measurement system for monitoring suspended sediment in hydropower plants. For this episode, we have Sebastian Skifler. So let me first introduce Sebastian. So Sebastian, from 2020, he is associated in NIVOS, and he is now responsible in sediment measurement project. So Sebastian, you can start your presentation from here.
Okay, thank you very much. So I will start my presentation first. Okay, so now I hope you can see my presentation.
Yes, we can see.
Okay, so good evening, everybody. And well, my name is Sebastian Scheffler. It's I think for you a quite difficult name to pronounce. I'm from Germany, and well, I'm working at NIVOS. Well, it's a German company, NIVOS, since 3.5 years, and I'm working as a project manager for hydropower projects and for projects in surface water. First of all, I have to say thank you to the Nepal Hydropower Association to give me the opportunity to present you a quite new system for particle measurement in water. And well, in my presentation, I will first briefly introduce the company NIVOS, and then I will move on to the measurement systems, the Nivo ParkU 850. And I will first explain how the system works exactly, or how the measurement works exactly, and then I will show you the specifications of the system. And after it, you will see measurement data and the measurement site of 2 measurement sites in Switzerland and in India. And finally, I will show you the options for data transmission and for the connection to control systems in hydropower plants. Well, I know I have a quite strong German accent. So if somebody of you don't understand me, don't hesitate to interrupt me and to ask me. So I will start my presentation now, and well, this company NIVOS. So NIVOS is a German company, and it's based in a very small city called Eppingen. It's in the southwest of Germany. The company was founded 50 years ago, and it's still owner managed. Actually, currently we have around about 150 employees worldwide, and the company's main expertise is in the development of ultrasound measurement systems. So we have over 20 years of experience with ultrasound flow measurement, and also our new system, the particle measurement system, is working with ultrasound. Well, worldwide we have 8 subsidiaries and 40 distributors. And as I mentioned before, the main expertise of the company is flow measurement, so flow measurement with ultrasound. And here we can see the fields of activity of NIVOS. So we are active in sewer networks, in wastewater treatment plants, in hydropower as well, and in surface water and in drinking water. And now I will move to our actual topic, to the measurement of suspended sediment concentration in water, and also of the measurement of particle size distribution. And this with a quite new measurement system, the Nivo ParQ 850. Maybe a short background about the measurement system. Nivo launched this system almost 4 years ago, and the system was developed more for the use in stormwater and in wastewater. And 2 years ago, I heard about this increasing problem of the erosion of the turbines in hydropower plants, and so we could adapt the system to the conditions of hydropower. Now this slide shows you how the system is working, and I think this is something very important. That the operator or the user knows exactly how the system works. So what you can see here, I hope you can see my mouse. So what we can see here, it's the right side is the sensor, and what we can see here, we are working with 4 ultrasound transducers, and with these 4 transducers, we can produce up to 10 frequencies. So we are working with a multi-frequency method, and with this 10 frequencies, we are using the backscattering and also the attenuation of the signal. And with this 2 parameter, we get information about the volumetric concentration of particles in the water, and also we get information about the size of particles. So we get the volumetric concentration in ppm, so in parts per million, and we get information about the particle size distribution. And then we have to enter in the transmitter, in the unit, a mass density. And for hydropower, we use the default value of 2,650 kilogram per cubic meter. That's the value of the quartz mineral. If the operator knows by samplings the actual mass density or the actual mineral, they can also enter this mass density into the system to get an even better measurement. Well, and with this measurement of the volumetric concentration and the size particles, and with the mass density, what we have to enter into the system, we get the measurement of the mass concentration in milligrams per liter. And with this, we are able, well, until now, we are able to measure the concentration in the measurement range from 10 to 6,000 milligrams per liter. And this without any calibration. And in 2 or 3 weeks, we will launch a new firmware. And with this new firmware, we will be able to measure within a measurement range from 10 to 50,000 milligram per liter or even more. And what we also get is our information about the particle size distribution. So the particle size. The particle size distribution is divided into 5 classes. So we have the smallest class here, particles 563 micrometers. Then we have the second one between 63 and 100 micrometers, and so on. So 200 micrometers, 400 micrometers, and the largest one is particles between 400 and 1,000 micrometers. And the measurement, or we can measure these values with a measurement uncertainty of 10% up to 2,500 milligrams per liter, and then linear increasing to an uncertainty of 20% up to 50,000 milligrams per liter. At the right side, again, you can see the sensor here. I just put it the length of the sensor, and for just you that you can get an idea of the sensor. So this is more or less 27 centimeters. You have a picture of the transmitter. And now I'm going to show you some or two measurement sites. One measurement site is in Switzerland. Maybe this looks like a little bit like also in Nepal. So what you can see here is the water intake, or one of the water intakes of a power plant in Switzerland. So we have here the river coming down from the mountains, and maybe you can see here the inlet screen where the water goes into the water intake. And well, what I forgot to admit, what I forgot is that the sensor can be installed almost everywhere. So you can install the sensor in open channels, in rivers, but also in penstocks and full filled pipes. And at this water intake in Switzerland, we have installed two sensors. The first sensor we have installed just in front of the inlet screen. So here is the inlet screen, and here you can see the sensor. The sensor here is protected with a very thick housing from debris. And the second sensor we have installed in the desilting chamber right after the sand trap. So here, this is the sand trap of the water intake, and we've installed the sensor here where the red arrow is. And here you can see again the installed sensor. And this slide shows you some measurement data from an event in August 2023. So the aim of this measurement was to shut down the water intake, or to shut down the power plant at a concentration above 5,000 milligram per liter. And what we can see here is an event. This is just a small event with a peak of around 4,500 milligram. So the red curve shows us the total concentration. And then also we can see the particle size distribution. So the green curve shows us the concentration of particles 563 micrometers. And the yellow curve shows us the particle concentration of particles between 63 and 100 micrometer. So what we can see is that almost all sediments consists of this small particle sizes, and only here in the peak of the event about midnight, we also could measure particles up to 200 or even up to 400 micrometers of size. Now I'm moving to the second measurement site. This is Tista Oria in India, and well, I'm sure you have heard about this power plant. I was there in June last year, and a few weeks later, this power plant was flooded because a glacial lake above the power plant collapsed, and then the dam was washed away. But well, the idea here was to first to install the sensor in one of the tailways. So the power plant was running with 6 turbines, and the plan was to install the sensor here at this corner of one of the tailways. But then the operator wanted to compare our measurement with samplings. So he wanted to be sure that that our measurement measured well. So so we find the solution to install the sensor in this kind of tank. And in this tank, the water was pumped through by a pump. So the water was pumped up from the tailways, pumped through the tank, and then it went down again into the tailways. And the sensor was installed here in this tank. And so the operator was able to take samples here in the measurement window of our sensor. And so he was able to compare our measurement with the results of the samples. And well, what we can see here is again some measurement data of this measurement site. And first of all, what we can see here, it's a red curve again, the total concentration. We have here a very, very low concentration of round about 80 milligrams per liter. And also what we can see is that the red curve indicating the total concentration lies above the blue curve. So this means that almost all the sediments consists of very, very fine particles, finer 63 micrometers. And then an event started, and the total concentration went up. And what we can see is when the total concentration increases, also the proportion of the concentration of the particle size 63 to 100 micrometers increases, and then decreases again when the concentration decreases. So I think this is something typical, but also something very interesting. Well, and in my last slide, I will give you some information about the communication possibilities with the unit. So there is an internal modem integrated, and also we have 4 analog outputs to get out the measurements to the control system, and we are also working with Modbus TCP and Modbus RTU. And again, back to the internal modem. So with the internal modem, it's also possible to push the measurement data into a Nibus cloud, and then from the Nibus cloud by an OPC interface into the control system of a hydropower plant. So thank you very much for your attention. And now I'm eager to hear some questions about the measurement system. Thank you.
So thank you, Sebastian, for your nice presentation. So here is the one question from Nitish Sapkota, and he is asking about the cost involved for all these process.
The cost of the whole system, so consisting of the sensor with the transmitter unit, is around about 60,000 euros. So 16,000 euros. Some more questions?
Hare Krishna ji.
Sebastian, I think Hare Krishna Sreshta wants to raise some questions. He has raised the hand.
Yeah, I see it.
Can you unmute, Hare Krishna ji? Yes.
Can you hear me?
Okay, now.
Sebastian, is this system useful for monitoring the suspended sediment in rivers, open channel, like rivers?
Yes, it is.
Do you have examples of such things in somewhere in Europe or somewhere in India?
No, until now, no. But this site, the one site I showed you in Switzerland, there's the sensor is still installed in the river. The only thing you need to know is we have a measurement window of more or less 40 centimeter. So we can measure into the water around about 40 centimeter, not more. So it's more or less a punctual measurement.
You can use it for monitoring the sediment, suspended sediment of a river system, right?
Yes, that's possible.
And how do you calibrate this its data? Whatever data is getting, how do you calibrate it?
Well, it is what we do still in the company is we calibrate every system with some kind of quartz minerals. So this is our calibration, and the only calibration you have to do as a user is to find the accurate mass density. So you have to know which mineral you will find in the river. That's the only calibration you can do.
Yeah, there will be quartz and other types of clay minerals also. So
Also, you just have to know the mass density of the minerals. So if you have quartz, you can use the quartz one. If you have another one like glimmer, you use the mass density for glimmer.
okay.
Yeah.
So
But you can use it for sediment management, and I think the big advantage of the system is you are able to detect sand, for example. So because for example, if you work with just with turbidity, you don't get information about the particle size, and I think this is our big advantage, that you get the information about the particle size.
okay, sounds good.
Yeah.
So here we have another question from Nitish Sapkota. So please unmute your mic and you can ask.
Thank you, NHA. Hi, Sebastian. It was a nice presentation. Hello. I have two questions. Yeah.
Yeah.
Is it like depth integrated, or up to which depth we can measure the sediment? Because you know that these suspended sediments are they are different at different depths. Yeah. So what about it? And up to how much turbidity it works? This system.
Well, let me go back to the specifications. I hope I understood you well. So we can measure at least up to 50,000 milligrams per liter. I don't know what this value means in turbidity. This I don't know, but we can measure up to 50,000 milligrams per liter.
Okay. Okay.
And regarding the depth,
yeah.
I don't know if I understand you correct, but you can install it, for example, in different depths in the river. So you can measure at the first depth, and then at the second, and then at the third. Is this your question?
Okay, that means that I have to keep 3 sensors for different depth if you want to get an average depth value, or like depth profile.
Well, you only can connect one sensor to one unit, but
Okay.
maybe you can find a solution, or you can find a construction to move the sensor.
Okay. Okay.
This can be a solution, because the sensor, there are two versions of the sensor. There's one version coming with a pressure sensor, so you can so you will also get information about the depths.
Okay. So like Sebastian, like in Switzerland, the rivers, I think they don't have boulders, yeah. So they are fine sediments without boulders. But in Nepal, there are boulders, and keeping this sensor in the intake or trash strike might these boulders hit this sensor. So do you do any protection work for this sensor?
Well, let me show you again this picture. So here you can see the sensor, and here and here you also can see boulders. So the sensor has to be protected with a very thick housing.
Okay. Okay.
But this is something up to the operator, because the operator know what is happening in this in the system.
Okay. Okay. Thank you.
Thank you.
Sebastian, I have a question.
Yeah, tell me.
Actually, like you install this sensor in the bank of the river, right? In the in the center, is it it's not possible to install it in the center, right?
At the center.
Yeah, because like in a river, the concentration of the sediments depend on the velocity of the river. The maximum velocity, there will be more concentration, right?
That's true. Well,
Then yeah, how if we take one cross section and we install it in the bank of the river, then how will it like it will be the representation of the concentration? It will it be a good representation of the cross sections?
oh, that's difficult. That depends of the measurement size. But also what I also can say is that if we have the sensor here like this, we
Yeah.
only measure in a window up to 40 centimeters. So you get information from this distance, not more. If you want to have information about the cross section, you have to find constructions to move the sensor, because if you install it in the middle at the bottom of the river, I think the sensor will be trapped immediately.
Yeah.
So
that's true.
that's yeah. Well, we have flow measurement solutions at floaters, so floating at the water, and measurement and measuring from up to down. So this also can be possibilities.
Okay.
But this is more up to the user. We only can deliver the measurement system.
Yeah.
Yeah.
Okay. You said the range of the concentration is like 60,000 ppm, right?
No, 50. Well,
50. 50.
well, at least
Yeah,
50.
yeah.
Maybe even more. But 50,000 milligram for sure.
Yeah. Like as I know, in Nepal, 50,000 ppm is like
No.
an average concentration in a monsoon season in a river. We have got lots like sediment. So
but,
how
wait, I'm not speaking about ppm. I'm speaking about milligrams.
Yeah, isn't it ppm, milligram per liter?
No, nothing at all. So ppm means for you, you get samples with a Imhoff, what's the name of it? With the Imhoff class, and then you wait until the sediment settles down, or how you get it? No, how you measure in ppm?
Actually, we collect the sample with water from the river, and then the easy method we adopt here is like filtration method, and we weight the whole sample, and then we dry the sediment sample. We weight that, and by calculating those remaining samples with respect to the whole sample, we calculate the ppm.
Okay. So it's more or less the same. Yeah. Okay. You can use it more or less. Yeah.
Yeah. I think that is the method how we calculate ppm, right?
Yeah. So
I think it's like mg per liter. Like, you make me confused now.
No. Yeah. It's more or less the same. But this discussion I also had in Tista.
Yeah.
Because they did it the same way. No. Yeah. You can use milligrams also, or you can use milligrams per liter also
ppm.
at ppm. Yeah.
Yes, because I work in like sediment lab for many years.
Yeah. Okay.
And
Sorry.
I have no, don't be sorry for that. No, I have experienced that there have been more sediments than 50,000 ppm. So is it like how can you say that it's useful for Nepali rivers, like Himalayan rivers, with lots of sediment?
No, it is just we just can define the measurement, or we can just define the measurement range of the system. If you need a even wider measurement range, maybe you can't use it.
Oh.
This is well, we will launch the new firmware in 2 or 3 weeks, and then I can say you for sure up to which concentration we are able to measure. So maybe it's 60,000 or but yeah.
Okay. Oh, then can you like increase the range of the concentration in your sensor?
No.
No. Okay. You have to reset design.
Yeah.
Okay.
Yeah.
Thank
I
you.
can
Thank
say
you very much for your answer.
Okay.
Yeah. Madanji, any more question?
Yeah, Hare Krishna Shrestha.
Yeah. I have one more question. The EMF cone is very new in Nepal. I have not seen use of EMF cone in Nepal much, but it's one of the recommended method for mostly for scientific purpose rather than direct measurement of sediment concentration in rivers. Although it can be done, but it's new in Nepal. So,
okay.
What is the specific limitation of only 40 centimeters on the sensor? What is the science behind it? The limitation of the sensors?
Actually, I don't know if it's my connection or if
Can you
it's
hear
yours
me?
connection. Almost no.
Maybe my connection. But
yeah, please.
I will repeat it. What is the reason for the limitation of the sensor that it will detect the sediment concentration only up to 40 centimeter?
You mean this the limitation of the strength of the signal?
Yeah.
Well, because
yes.
because we work with we work with the backscattering of the signal. So we push signals out and then we get them back. So we get back the backscattering from the particles. And beginning with 40 centimeters, we don't can how to say, we are not able to process signals.
Okay.
It would be possible if we would work with bigger transducers. But until now, this is the sensor like this.
Okay. Does it have to be horizontal? Can it be vertical?
Yeah, it can be installed like this. You can see it. This is a sensor.
Yeah.
You can see you can install it like this. You can install it like this, vertical, or also from up to down.
Now the sensor can be vertically installed, not horizontal, vertical.
Also, you can the sensor can be installed very easily and vertical, horizontally, how you want.
Okay.
It is if somebody of you has a measurement site or a potential measurement site for this measurement system, just send me some pictures about it by email, and I can and we can discuss how to install the sensor, how to measure there. And maybe also one more limitation of the measurement. At the site, there must not be air bubbles in the water, because air bubbles influence the measurement. This is something very important.
Okay, thank you very much.
Thank you. I think there's some more question from Sudesh Maskai.
Hello, Sebastian. Thank you for the presentation. If you could go back to the presentation where you showed the sensor in the intake.
This way.
in front of the intake.
Yeah.
Yeah. It seems that the sensor is facing downstream, huh?
Yes. Yes.
Is it always necessary to have this sensor facing downstream, or we can also face it in the upstream, like in the, I think in the settling basin, it's facing downstream or upstream?
It's every time it's downstream because because we have to protect the transducers from dangerous. Because here the housing is here the housing is closed. It's a rear part.
Okay, so the counter question, because as Hari sir asked, we can install it vertically. So how would we install it if we install it vertically? Because then you will have the flow coming in down at the bottom of the sensor or at the top of the sensor, right?
So you mean the sensor looking up? So
Looking up
from,
or looking down, yeah. So that's what I think Hari sir was questioning, that whether it could be installed vertically or not.
It is possible. It is possible. But if you install it looking down or looking up, you just have to be sure that you have the distance to the top of the water, to the water level, or to the bottom of at least 15 centimeters.
Okay.
So we need 15. So we need 15 centimeters for the measurement. And then and then again you have to find a way to protect the sensor from debris or from boulders.
So I think this is the recommended way to have the sensors facing downstream.
Yeah.
Okay. Also, I think you mentioned that we could install this sensor in the penstock.
Yeah.
So then also this sensor would be facing downstream, huh?
Yes. But this is just due to protection reasons.
But how will so this protection system needs to be designed by the client, or you design it in case of the penstocks?
This is done by the clients.
By the clients.
Yeah.
Okay.
And
because in the penstock you'll have a higher velocity.
And well, okay. Two more important things. We have a pressure limitation of 4 bars, so 40 meters of water above the sensor. That's the maximum we can get, and we can measure up to 3 meters per second flow velocity.
Okay.
Because
so that means,
because after or at higher velocities, there's a danger of air bubbles due to cavitation.
Okay, so because in the Himalayan rivers, what we have is a very mixed nature of sediments. So we do have quartz, we do have feldspar, we do have clay particles, and mostly dominated by quartz and feldspar, and of which the weight are quite similar. How could we do the distinguish between those two with your sensor?
No, you can't. You just can enter a medium mass concentration of this of the minerals you have. So if you have samples and half of the particles are quartz, and half of it is another mineral, so you can use the medium.
Okay, so basically we are measuring the concentration rather than the particle itself, or they say quality of the particle, minerals of the particle.
Yes, we don't get information about the quality. We only get information about the quantity and the particle size.
Okay. One last question. You said something about 16,000 euros for the financial part. Have you installed one of these in when you installed one of these in the India? How was the procedure that this 16,000 euros also involves your costing, that you'd come and install it, or you just supply it and everything else is done by the client?
Well, in Tista in India, it was like a pilot project. So myself, I was there to do the commissioning, but actually the commissioning, or well, actually, the installation and the commissioning of the system is quite easy, and we can do it online. So that the customer just install it. I can help it to find a application, a good site, and then the commissioning can be done online, because it's quite easy.
Okay.
And I will help to find the right site for the installation. That's for sure. And in Tista, this was also a cooperation with Andritz India, so with Andritz Hydro, and this was something like a pilot project.
Yeah. Okay. Seems like this is quite a good equipment. I will be in touch with you after maybe tomorrow. I'll send you an email regarding more descriptions about the equipment.
Perfect.
Yeah?
Thank you.
Okay.
Thank you.
Thank you. Thank you.
So Sebastian here, we have another question in chat box.
Yeah.
So the question is from Sitish Shrestha. He is asking, what are the periodic requirement of maintenance?
Oh, good question. Thank you. There is no maintenance actually. So you don't have to clean the sensor every few weeks. Well, maybe you have to clean the sensor every or once a year. This would be nice, but there's almost no maintenance needed. No calibration and no maintenance, because since we are working with ultrasound, we can sway to a biofilm. So biofilm doesn't influence the measurement.
Thank you. So here is another question from Jivan Kumar Bon.
Yeah.
He is asking that is there any limit of concentration that it can measure?
Well, as I showed before, we have, or we will have with our new firmware, the limitation of 50,000 milligrams per liter, or if you say it in 50,000 ppm. Maybe even a little bit more.
Okay. Here you can see Smriti Gautam is asked. She will please ask Sebastian.
Hello, I have two questions. So
Yeah.
how frequently does this sensor collect this sediment data? Can we adjust number of sampling based on our needs?
Sorry, I didn't understand it. Can you say it again, please?
Like how frequently can this sensor collect the sediment data?
Oof. Wait, we measure 1,000 times per second, and you get a value every minute. No, every half a minute. So it's a online measurement.
And how can we extract those data?
You can, let me move again to the connection system. So, well, we have at the unit, we have 4 analog outputs. So analog outputs meet 4 to 20 milliamps. You can send to our control system. You also can get it as a CSV or CSU. Sorry, what's in English? CSU. CSV. Thank you. Yeah, you can get it. You can get the data as CSV, and also you can send it by Modbus TCP and Modbus RTU to our control system. We work with Ethernet, TCP/IP, and we also have, as I mentioned before, we have the internal modem, and you can send by this modem, well, by HTTP to a server or by our Nivus cloud to a server.
Okay, I have one next question.
Yeah.
When we sensor in structures like descender, penstock, how can we power this sensor?
How can I say it again, please?
When we install these sensors in the structures like penstock, right? How can we power? How is the what are the power options for this sensor?
What do you mean with power? The power supply?
Yeah.
Well, okay. We have you have two options. We have an AC option and also a DC option. So 100 to 230 volts AC or 10 to 32 DC. Was this your question?
Yeah.
Okay.
I was
Yeah.
the same. Thank
So there is another question from Jivan Kumar Bon. The question is like, what will be the working capacity in white water condition? I think white water means clear water.
Can you repeat the question? The first part.
What will be the capacity, working capacity in white water condition?
This question I don't understand. Well, I understood it, but I don't understand what it means.
I think
the capacity
asking in clear water, for clear water is asking the working capacity.
But I don't know what he means with capacity in clean water. Sorry.
No, he's asking for turbulent
the question is about what is the minimum limit, lowest limit of concentration you can monitor.
The minimum limit. Okay, it's well in my presentation I've put I think 10 milligrams. Yeah, 10 milligrams is the lowest concentration. Let's say 20 milligrams. I think 10 milligrams sometimes will be difficult. So 20 milligrams.
I think that question was not like this. I think for a turbulent condition, like in rivers in Nepal, the rivers have high velocity and they have like turbulence. Yeah. So in those conditions, like how can it work properly and what is its capacity, or it can work properly or not? I think that was the question. I think.
Okay. Thank you. Turbulence doesn't affect the measurement, but what do affect the measurement are air bubbles. So if you have air bubbles at this site, well, air bubbles will seen by the measurement system as particles. So you have to avoid to have air bubbles in the water. But turbulences doesn't affect the measurement. I hope this was the question now.
I hope too.
Yes, he was asking for turbulent. So Smith Gautam is again raising his hand. So please, you can ask.
I forget to load down.
Okay, no problem. So here is another question from Suresh Oli.
Yeah.
So you are talking about, you're saying that concentration limit. So he is asking that can we measure? Does it mean we can measure more than 50,000 milligram per liter suspended load with great uncertainty?
Yes. So we still will have measurement data, but with the uncertainty. But let's wait until we are finished with our new firmware. So we will be finished in 2 or 3 weeks, and then maybe I can share the final measurement range by email to you.
So he is again asking that actually in Nepal, depth of flow varies significantly within the year. So in such case, shall we have to be installed sensor at a different depth?
If it's necessary, yes. So if you well, yes, if you have to move the sensor, or if you have different depths, or if you can't install the sensor in a certain depths where you every time here you have water, you have to move it. So, for example, at this site in Switzerland, in winter time, so the installation was done in winter time. So we at this time we have no water here. But this doesn't matter because the operator only wants to measure from May to October in the year. Was this your question?
I think.
But I think it's not so difficult to find or to construct a construction to move the sensor, so that you have it for a certain time at this height and for a certain time at this height. That's not so difficult.
Okay, so here is another question from Anup Khanal. He is asking, we have seen some optical backscatter OBS sensors in the market applied for some application. How do you differentiate your sensor with OBS in terms of accuracy of measurement?
Can you
like he is saying some sensor, optical backscatter OBS sensor. So how do you differentiate your sensor with OBS in terms of accuracy?
This I don't understand. Well, optical sensor means with laser or with or with turbidity, with light.
So I think he is asking some other application of sediment measurement like OBS sensor. Is that sensor sediment measurement or not? I don't know, but
well, it is. Well, you have. I think right now there are 3 different methods at the market to measure the concentration by turbidity, by Coriolis measurement, and by backscattering with ultrasound. And well, the big disadvantage of the turbidity sensors is that you have to clean it every few weeks, and you have to calibrate it every few weeks. And well, that's the difference. Or what do you mean?
Okay.
Any questions?
One last question for you. This is from Sri Sreshta. So, is there any velocity limitation of flow for the device?
Yes.
And there is also another question. Will the accuracy will be what will be the difference in accuracy for slow flow and the fast flow?
Okay. Well, the maximum velocity where a measurement is possible is more or less around 3 meters per second, because above 3 meters per second there's danger due to cavitation to get air bubbles due to the sensor in the water. But there's no difference in the uncertainty. So it doesn't matter if you measure at the low velocity or at the high velocity.
I think there is not any other question for now.
Maybe can I suggest one thing? Maybe every one of you with questions maybe you can collect your question and send it to me, and I will respond it to the question by email.
Okay,
yes, that would be nice. If anyone has any questions, we can you can email to us or email to Sebastian so that he can answer the question.
Yeah, I think this would be a nice option.
Okay, Sebastian. So at the end, I would like to say some thank you note to our General Secretary of Nepal Hydropower Association, Nirmala Lama. So Nirmala Didi, can you say some words to Sebastian?
Yeah. On the behalf of Nepal Hydropower Association and HE, I would like to thank you, Sebastian, for your presentation. Nice presentation, and we hope we will have more connections in future so that we can work like a bridge between between all those hydropower people projects which needs your product, and if they want to buy your product, and if you want to say something to our developers or stakeholders, we can be the bridging organization for you guys. So thank you so much. We have been in touch since so many months, and finally we successfully conducted this session. Lastly, thank you very much, Sebastian, and it was nice meeting you there in Edinburgh and here in Nepal.
Thank you very much.
Yes.
Thank you for all, and good night.
Yeah, good night.
Thank you.